Saxon Algebra 2, Lesson 53. Greetings, students. Welcome to the beginning of your second week of math, back from our break. Let me thank you for being flexible with the whole weird messaging check-in thing that I did last week, and let me tell you what happened, because it was kind of, it was all unplanned and somewhat unpredictable. Here's what happened. For my birthday, which is New Year's Day, my eldest daughter gave me a surprise trip to the beach. She took me to Kalaloch, which is in Olympic National Park, which is on the coast of Washington, about in the middle, north and south, which was fabulous. We went out there. We go camping there all the time, but we've never gone in the winter. They have some cabins you can stay in, bougie cabins. So it was really nice. We had a great time, and I thought I had a really great plan. I recorded all of my lessons before I went, and then I could post the links to you, at the right time. And I thought, perfect, I can do my check-ins from the cabin. I'll just FaceTime you from there. No big deal, right? Because they have service at the cabins. The problem was they didn't have Wi-Fi, and yeah, they had service, but it wasn't service. If you know what I mean, it was service, but it wasn't service. And after we'd been there for a couple days, I thought, oh, if I try to FaceTime, it's going to be a nightmare, because you know how that is, a bad connection. It's going to be just terrible, and we're all going to be annoyed, and I don't want to make you cry the first week back after Christmas. So that's why I decided I'm just going to check in by text, because that will be so much smoother and better. Okay, so that's why we did what we did. This week, and from here on out, we're back to normal. We'll do the regular check-ins the way we did them before Christmas. So FaceTime, let's see, Micah, you have a standing appointment at what time? 1 p.m. on Thursday. And Abby, you have a standing appointment, what is it? Is it like at 2 o'clock? I'm not sure. I have my notes around me somewhere, but I can't think of what time it is. Whatever time you usually call me on Thursdays, call me at that time. Kyle, you usually call me on Fridays, a little bit later in that block of time from noon to 3. Just keep doing whatever you like to do. If you have found that your schedule's changed and your standing appointment, Abby and Micah, doesn't work as well for you this year and you want to renegotiate, that's fine. Just message me and we'll figure it out. But I will look to see you two specifically on Thursdays at those appointment times. And Kyle, you and I can just check in on Friday whenever you want to call me. You know I'll be there from noon to 3. So no more messaging. Thank you for telling me about your food. I got hungry reading your messages. But now we're back to normal. Thank you for being patient. Okay, lesson 53. We're going to talk about unit conversions first. It's not horribly long, but I hate when John gives us multiple parts. It's just annoying. Okay, first example is a unit conversion where we're going to start in the metric system and we're going to convert to another measure that is also in the metric system. So it's metric to metric. Convert 7,560 centimeters to kilometers, okay? Nothing squared or cubed, so it's just a conversion of length. And we know to go from centimeters to kilometers, well, let's see. First, we'll want to go from centimeters to meters, and then we'll want to go from meters to kilometers, right? Meters is kind of like the touch point. This will be over 1. We'll be multiplying all of this, and that will be our answer. All right, so in the first one, we want to go from centimeters to meters. Centimeters are on the top, so we want those on the bottom. Meters go up there. What's bigger, a centimeter or a meter? I wish you were here to help me answer all these questions. Meters are bigger. There's 100 centimeters, because cent, right? Okay, beautiful. These cancel. We're left with meters. That takes us into this one. Meters are on top. We want meters on the bottom. Kilometers will go up there. Kilometers are bigger. These are the things that measure on the expressway. Your dad is probably about 2 kilometers tall. That's how I put those in perspective. Centimeters are like the size of your knuckle, right? They're smaller than an inch. These are an inch. I don't know. It's like the width of your finger. Kilometers are bigger. Kilo implies 1,000. So we know there's 1,000. Whoops, 1,000. All right, now the meters cancel. We're in kilometers. That's where we want to be. So now our answer is 7560 on top. Those are just ones. And on the bottom, it's 100 times 1,000. Now, that's the right answer in the form that we usually provide for these problems. But look how easy it is to simplify when we're in the metric system. We just write 7560, and then we're going to divide by 100, which is 2 jumps to make it smaller, and then by 1,000, which is 3 jumps. 1, 2, 3. So we can easily simplify this to say that this is, I'll put a 0 out here. Our final answer, this, simplifies to 0.0765 kilometers. So metric to metric conversions are so sweet because everything is just 1,000s. So we can just jump the decimal to simplify. And that is the beauty of the metric system. Maybe someday the US will get on board. Let's do another one similar, just so that you know that wasn't lightning striking. They're always that easy. 15,740,000. 15,740,000 square centimeters. So I'm going to write it twice. To square kilometers. All right, so we're taking the same journey. We're just doing it with squares instead of, excuse me, instead of this is length, this is area. We know, right? Because it's square. So we're going to have to do the same adjustments. This will be from centimeters to meters. This will be from meters to kilometers. But we're going to have to do this one 2 times and that one 2 times, right? Because we have to convert for each dimension. All right. Centimeters on the bottom, and I'm going to write it twice. And meters on the top. A meter's bigger. There's 100 of these. Centimeters cancels, and we're left with meters. Okay, that's where we want to be. Meters on the bottom. That's 1. No, that's not 1. Kilometers are bigger. So that's 1. There are 1,000 meters in a kilometer, right? Kilo, that prefix means 1,000. Now the meters cancel top and bottom. Kilometers are left, but that's exactly what we want. Now we're ready to multiply all of this. We just have to be careful because it's set 15,740,000 other ones across the top. So now we can go to the bottom. 100 twice, so it's 100. I'm going to write this out instead of using squares. And then 1,000 times 1,000. I'm writing it out because I want to see all those zeros to make sure I know how many jumps to make. Now, granted, I could do it with exponents too, but I'm just sort of doing this in, I'm baby stepping you into the shorthand so that you don't get lost. All right, so I'm going to rewrite 15,740,000. There's my decimal. I'm going to start dividing. First, 2 jumps, then 2 more, then 3, and then 3 more. So that would be 0.00. I'm going to rewrite it so it looks like an actual number and not my scribbling. 0.001574 kilometers squared. 0.001574 15748. That's the right answer, okay? So again, we have proven beyond a shadow of a doubt that the metric system totally rocks when it comes to simplifying these answers. All right, now we're going to try some other problems, 2 more of them, that are English units to metric. And you know what? It's not that it's hard, it's just so much messier, right? So let's do example 53.3. Use unit multipliers to convert 32 yards to meters. We have to go through the portal, you guys. Okay, so let's figure out what the crossing the stream is going to look like. First, let's pretend we know how to go from yards to inches, because that's going to make this a lot simpler. If you don't know, there's 36 inches in 1 yard, and 1 yard equals 36 inches. Most people know that there are 3 feet in 1 yard, but we also know that there are 12 inches in 1 foot. So if you can put those 2 together in your head, then you can get to this place, and then you can go from yards to inches in 1 jump. If you need to do it in 2 jumps, that's how you would do it. But I think most people can do the summary. Then we'll be in inches. Then we can go through the portal to centimeters, and then we'll go from centimeters to meters, right? And we have to do each of these twice because we're in squareds or areas, we know. Ay, right? Okay, so we've got our roadmap all laid out. We've condensed. We could be doing this in another step, right? If we wanted to go from yards to feet and then feet to inches, then we would have 4 different multipliers that we had to use 2 times each. We would be up to 8 multipliers. As it is, we're just going to keep it simple and do only 6. Right? Okay, so we're going to want yards at the bottom. I'm writing it twice so that I can cancel. Inches up here. That looks good. That's how we want it. And then a yard is bigger, and there's 36 inches in a yard, right? 3 feet, 12 inches in each foot. Okay, we're good. Now we're in inches. Now we go from inches to centimeters. So we're going through the portal here. We know an inch is bigger, and we know there are 2.54 centimeters. Cancel, 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 cancel. There's what we're in. So now we know we want centimeters down here, meters up there. You're working with me, right? In this case, a meter is bigger. Centimeter, there are 100 of those in a meter. These cancel. We're left in meters, and that's exactly where we want to be. So now all we have to do is gather up our numbers. It's 32 times 36 squared times 2.54 squared, and then we don't have to do the 1, over 100 squared, and then our unit is meters squared. I don't know about you, but I don't want to try and simplify this like we did with the metric to metrics. They were so easy, right? Let me just check the answer. 32 times I made this problem harder than it needed to be. It wasn't actually squared. It was just one-dimensional. It was just yards and meters. So we didn't have to do those times 2. So I tricked us into doing a harder problem. This is correct. We did it correctly. I just made the problem harder than it needed to be. So, oops, sorry. But that's the problem with English units, is they just have these wacko random numbers in them, and they're so messy. Let's just do the other one, even though it's basically as hard as I made that one. Sorry. Okay, this time we're going to go from 0.042 square kilometers. So now is when we're supposed to be doing the square. To square miles. Notice that meters abbreviates as M, miles is MI. Okay, so let's plan this out. We have to go from kilometers to miles, and we have to use everything twice because it's a square. First, we'll go from kilometers to meters. Then we'll go from meters to centimeters. Then we'll go through the portal. We'll go from centimeters to inches. Then we'll go from inches to feet. And then we'll go from feet to miles. And we have to do each of those twice. So look, you guys, we're using 10 unit multipliers. Do you remember back in the day when we would just use 1 or 2 and it seemed impossibly hard? And I told you it's going to get harder. Well, guess what? It did. It got harder. We're going to make it one step further from here harder, but this is, you're in the worst of it now. All right. These are all going to be fractions. Kilometers to meters. That means we need kilometers down here. I write it twice so that I can cancel properly. Meters are up there. Kilometers are bigger. Kilo represents 1,000, so I know that goes there. These cancel. Meters. Meters are down here. Centimeters are up here. Meters are bigger. 100. Let's cancel these. Okay. Once you get the groove of this, it kind of is fun, isn't it? It's sort of satisfying how you can just like cruise along, plan how you're going to cross the stream, just knock out all of these unit multiplier conversion numbers. I hope you're at that place where it's feeling like, okay, I'm in the zone here. It's happening. All right, centimeters to inches. We want centimeters on the bottom, inches on the top. Inches are the bigger. 2.54 centimeters. Okay, centimeters cancel. Inches to feet. Inches on the bottom. Feet on the top. Feet are bigger. 12 inches in a foot. Inches cancel. Feet to miles. Okay, feet on the bottom. Miles up top. Right next to the miles we wanted to end up with. Yay. Feet cancel. Mile is bigger. How many feet in a mile? This is the one everyone struggles with. 5,280. All right. Remember, each of these boxes actually represents 2 conversions because we have a square, an area. So we have to do 1 conversion for each dimension. So we'll have to put squares on these, right, when we do our final summary. So it's 0.042 times 1,000 squared times 100 squared, 111, don't need those, over 1, don't need it, 2.54 squared times 12 squared times 5,280 squared, and our final unit is miles squared. And here's John's. Look at John. For reasons I can't explain, he chooses to put all the ones in there. I guess he's just being thorough. I don't consider that necessary or helpful. But let's see, he's got 2 1,000s, 2 100s, 2.54, 12, and 5,280. Let's make sure we have all those. Yep, 1,000, 100, 2.54, 12, 5,280. That's the right answer. Again, if this was metric to metric, it would be easy to summarize and just move the decimal place however many times we need to, but this is a hot mess. Sorry, English units, you are not the easiest thing to use. Okay, that is the content relating to that. Now we want to switch gears. And we're going to go back to talking about those chemical compounds that we were doing and add just one tiny step to those problems. So I'm going to flip. And we're preparing you for chemistry. Again, this is part C, and it's ignore that title for now. What we're going to do is we're going to go back to a problem like you're familiar with and work it through, okay? This is the molecule that we're building. It's a compound called, I don't know what it's called. Let's just write it out. Okay? That is the compound that we're building. That's the recipe, right? It tells us 2 atoms of this, 2 atoms of that, 3 atoms of that. Then we have the information that tells us the weight. Okay? Na is sodium. S, I believe, is sulfur. And the reason I know this is because my husband was a chemical engineer before he was an accounting major, and he uses chemical compounds for all of our passwords. I probably shouldn't tell you that. You could come break into the Stryker system, but all of our... It's so funny. Like our Wi-Fi password and all that stuff, it's all chemical compounds, all right? Sometimes they're isotopes. It's so nerdy, you guys. I cannot even say the words. Okay, these are the weights of the different atoms we're using. This is the numbers of them. So we make our little chart. And again, we don't have to understand the chemistry, you guys. That is totally not necessary. We know, though, that our chart's going to look like this. Right? I just list them in order. Then I put in the number of atoms of each that we'll need. That comes right from here. 2, 2, 3. Then I put in the weight. And if I want to be really clear, I can write atomic weight. This is the weight of each separate atom. 23, 32, 16. Right? Then I can write the total weight. If I have to put in 2 of these atoms and each one weighs 23, then the total weight is 46. 2 of these atoms are going to be 64. And 3 of those, let's see, that's 48, right? Now for the first time, I can add this up, right? It's because this gives me the weight of the whole compound. There's 10, 18... There's 10, 158 is what I get for the total weight of the compound. This is in grams, okay? Remember these first two columns we don't need totals for. And then what we usually do in the problems is then we get some actual data, right? And we use proportions to solve. This time, we don't have to do that. This time, what we're doing is we're finding the percent of the total weight. Okay, so we want to say in a molecule of this compound, how much of the weight is sodium, how much of it is sulfur, how much of it is oxygen. We've got the raw numbers, but we want it as a percentage. The total is going to be 100%. But all we have to do is take, for each of these different atoms, we take its weight and we divide it by the total weight. This one would be 64 over 158. And this one would be 48 over 158. And then this obviously is the total, so it's 158 over 158. That's how I know it is. Okay, all you have to do is the division on these. I'm not going to spend the time doing that. But we take it out to 2 decimals and we find out that the sodium works out to 0.29, so it's 29%. This works out to 41%. And this works out to 30%. And these should add up, right? 9 plus 1 is 10. 1, 7, 8, 9, 10. Okay. And I'll just do one of them so you can see. Let's do the 48. 48 over 158 can also be read as 48 divided by 158. Right? 48 does not go into that. I'm going to need some zeros. Sorry, I'm just drawing a little blank there. 48, 158. The decimal goes there. And it should work out as 3 because it's 30%, right? I'm looking at the answer. 3 times 8 is 24. I see. Then we subtract. Okay. And now we can bring down another 0. It doesn't go into that, so we'll have to bring down another 0. 15 into 60, 15 times 4 equals 60, right? But it's going to have to be, it can't be 4 because I've got that 8 on there. It's going to be too high. So it's going to have to be 15 times 3. And because we're rounding to do 2 decimal places, I can see that I'm either going to stay at a 0 or go up to a 1, right? And that's a 3, so that means that my final answer would be 0.30, and that equals 30%, right? So these are the division problems we used to get the decimal number that we then converted into the percent, okay? So that's the only thing that's different. All of this part of the chart is exactly the same as what we did last time. Now we're just using these individual numbers and that total to create percents for each one. And again, these are the final calculations, but this is how I got each one. That's not hard. This is the hard part. This part is just playing around with fractions to make decimals to make percents. All right? So part C, oh, there's another part to this. Oh my gosh, you guys, when does it end, right? Let me just read it to you. 53.5. What percent by weight of this same thing is sodium? Oh, okay, well, we already figured it out. Sorry. This is good for you to see, though, because in your homework it could trick you like this. What percent is sodium? Well, you might need to go back to the problem and figure out which letter is sodium. Is it the S? No, this is sulfur. And by the way, I would not expect you to remember this for this class. That's the oxygen. The Na is the sodium. It's table salt. Okay, so sodium, we don't have to do the whole thing over again. We can just go back to our chart because we already have it. The sodium is 46 out of the 158. There's the fraction. We do the division and we get 29%. So the answer is 29%. We figured it out in our other table. Yay. Okay, don't let those mess you up. If you're challenged by the chemical mixture problems, or not the chemical mixture, the chemical compound problems. The mixtures are the pouring and the dumping thing with the pharmacist. Those are crazy in their own way. But I'm talking now just about this style of problem. If these are making you crazy, tell me when I talk to you, okay? I don't want them to make you crazy. I want them to make you feel really smart. All right, finally, we have reached the end of lesson 53, the lesson that just kept giving. I will see you soon for 54. Farewell.